Thank you everyone for taking the time to join this webinar today. The topic is all about architectures and what to consider when planning, designing, and deploying a high performance multi-CDN setup. I'm Mariana, I'm the Director of Solutions Engineering at Varnish. I've been part of the company for 8 years. And today, the angle we're going to take really is a lot about solutions engineering. And I'm going to share some of the principles we use when planning and discussing CDN setups. There will be some best practices, some assumptions we typically take, and architectures we use as a reference, at least to get started with the initial discussions. And then, of course, the fine tuning happens afterwards, as each case is different from all the other scenarios. First of all, a couple of words about Varnish. I don't really know what's your expertise as participant is about Varnish, so I wanted to spend just very few words about it. Varnish is software. It's pure software, and we provide solutions for content distribution, meaning that we provide solutions for content delivery network. And when building and planning for a content delivery networks, there are important considerations we have to make. So we really want to have a setup where we have smart routing, smart load balancing. Of course, we need caching, but we also want all of this to be well packaged so that we can deliver and we can provide good quality of service, quality of experience, and performances for the end users. And on top of it, the trend we have seen lately in the market is that we want all of this to be smart enough to provide edge computing capabilities, meaning that we're looking at potential solutions for content distributions where we need to be able to decide and be data driven. So we're looking at something which is fully programmable, and Varnish is all of this. So if we have to simplify what we need when planning a CDN, I have this slide here because I wanted to touch on three macro areas, which is content delivery, traffic steering, and control plane. This slide here is mostly for you because I know we're going to record this webinar. And if you want to have a complete overview of the Varnish components, you can always look at this slide and understand what we offer. Today, we're not going through each of the solutions you find written into these slides. Today, the conversation will be much more architectural. So we're gonna touch upon the three different micro areas. But if you're interested in listening to or learning more about specific topics, feel free to drop me a message into the QA, because we can easily focus on each of these boxes here for hours, each of them really. But when considering a CDN, we want to make sure we can deliver content, and that's a content delivery macro area. It's also referred to as a data plane. Then we want to make sure we have an offering or we have a solution for traffic steering, traffic routing. And again, we want this to be smart and reliable at any given time. And last but not least, we want to have a control plane. And a control plane really is all about making sure we can administrate and orchestrate in the best possible way the content delivery network we have. But most importantly, the control plane is also responsible for data gathering and data collection. And the data we get out of a CDN is really, really important, because then it can be used to take data-driven decisions. And those data-driven decisions are typically the ones which will give your CDN a boost in performances and improve dramatically the quality of experience and quality of your service. Today, I won't have the time to go through data gathering, data collection, but if it's a topic you believe you would like to learn more about, or just have a conversation about it, please let me know, because I personally find it very, very, very interesting, and I would like to share some more with the rest of you as well. But now that we have set a bit the stage, what is Varnish, what we do, and what we offer, now we start diving deep into the topic we have for today, and that's multi-CDN, really. So I've decided to take this webinar and present way more architectures than I've ever done. And in front of us, we have a multi-CDN architecture. Again, if we look at it from the left, we have a traffic router, and that's a traffic steering component we have seen in the previous slide. To me, that's one of the most important chain or links of the full delivery chain. I'm confident that some of you remember the different traffic routers / DNS outages happening, which has happened during the last couple of years, especially during the COVID outbreak, when a lot of people just started consuming content online. So the traffic steering for a CDN setup is really, really important. Needless to say that it must be redundant, but it must be clever. And again, here we could be spending hours deciding if it is best to route traffic based on geolocation, or if it is best to route traffic based on latency. In my experience, there is no right or wrong. Most of the decisions depends on the underlying infrastructure, depends on the actual geographical location where you are deploying the setup. And another example, it depends on the geographical database you use to define the geolocation of every single client. But all in all, the traffic router is a very important piece of the CDN setup. Needless to say, in a multi-CDN architecture, you may rely on other vendors' traffic routers. Varnish software offers a traffic router, and again, that's pure software. And being software, it means that by definition, it can be made redundant, because you can run different services of the Varnish traffic router on different machines. And this will make sure that you have a traffic router at any given time, even if there are outages or unexpected that you need to handle. Remember, no traffic router, no entry point within your CDN, no experience whatsoever for the end user. So that's a very strategic piece of the full architecture. Then we have the block in the middle. That's the pure content distribution. That's where we cache content, that's where we store the content, and that's where we have to be very, very clever on how we want to do this, because scaling and making sure that a CDN is performant requires time, and if we don't do it properly, we're going to lose performances, but we also going to lose money, because building a CDN requires knowledge, it requires resources, which are people and actual hardware. So here we have to fine tune the discussion, and today really that's the bulk of the conversation we're gonna take today. And in a multi-CDN setup, we typically refer to a multi-CDN setup when we have different CDN providers. So this example, this diagram, it's not made out of nowhere. It is based on previous experience, and that's what we have seen working really well for some of our customers, and that's kind of the standard out there. And typically what we want to do when distributing content is that we want to have different layers of caching. Introducing different layers of caching may sound like overcomplicating the setup, but in reality, it it reduced it reduced the complexity of the setup, because it makes it possible for us to easily scale the different tiers, introduce physical and logical roles, and make sure we have business continuity within the CDN. And if you look at this diagram, I've pointed out a couple of well-known commercial CDNs. And just to give you an example, what we want to do really is that we want to have two tiers. The edge tier will be the layers taking on to the client traffic. So the goal for this set of instances, or this POP, or even a single node, will be to listen to incoming traffic. So all those nodes will have to do is to make sure we can keep up with unexpected peaks, potential DDoS attack, and even malicious traffic. Typically on this layer, I've seen customers using commercial CDNs, and together with it leveraging some Varnish nodes as well. I'll just give you an example. So if we look at the US and our where commercial CDNs will have points of presence, you will notice that most of them, they do have a great coverage and a lot of data centers on the East Coast and the West Coast, whereas the central part of the US is much more empty. So that's an area where most of our customers will still have clients and users to deliver content to, but that's also an area where commercial CDNs will not have the same coverage as they have on the coast. So a good solution will be to leverage the commercial CDN on the coast and deploy some of the Varnish nodes in the central region of the US. But I'll give you another example. On the West Coast, the Los Angeles area in the US is known to be challenging to deliver content to. And that's because it is extremely crowded. There is the density of the population is really high, and it is challenging for anyone providing content to deliver it with a good quality of experience for the end user. So one of the strategy which may be applied in a scenario like this one will be to leverage the commercial CDN and use the POPs they have available in the nearby the LA region, and deploy a few Varnish edge nodes as close as possible to the end users, meaning that those nodes can either be deployed on bare metal, or they can use cloud solutions. That's a way to improve performances and make sure you can deliver content to an area where population is really, really dense. And that's for the edge tier. And then we have the storage tier, the one over here. In this example, I've only reported a couple of Varnish instances, but there are also use cases where, other than the Varnish instances, you may also have other commercial CDNs, so other CDNs provided by other vendors. The reason why we only have Varnish nodes here is because that's what I've seen happening the most with some of the prospects or customers I've been working with. On this layer, what we really want to do is to try to cache as much content as possible. This layer is known as storage layer, and its role will be to do the heavy lifting part of caching. Basically, the goal for us when setting up a CDN is to try to deliver content either from the edge tier, or in the worst case scenario, find the content in the storage tier or the distribution tier. We don't want to go to the origin nodes ever, other than the very first time when we need to retrieve content. And that's this central part here. That's content delivery. That's the core of the content delivery network. And I'm gonna spend more words on this because today really we're gonna focus on the different roles, the physical roles, logical roles, and the different principles we have when building a CDN. And on the right, again, last but not least, unfortunately, we won't have the time today to go through this, but we have the monitoring and the CDN administration side of a content delivery network. And here it is really, really important to make sure that when we work in a multi-CDN setup, obviously every vendor will come up with its own solutions. And what is important to us is to make sure that Varnish can be very well integrated in existing systems or with other CDN solutions. So that's something we're gonna touch upon in the upcoming slides too. But again, just to summarize, traffic steering, content delivery, or a distribution layer, if you will, and CDN administration and data gathering and data collection. So that's really what we need to consider when building and planning a multi-CDN setup. Now, before we present and we dive deep into more architectures, I want to share something with you all, and those are the principles we use when planning a CDN. When you read these principles, I'm sure you're gonna think they are obvious, because that's something that's something you will obviously expect from a CDN. But when you start the technical discussions, then it's super easy to get lost into other details and forget about those principles. In general, from a CDN, why do we build a CDN? We build a CDN because we want to deliver content, and this content must be available at any given time. So availability is a must-have from a CDN setup, no matter if it's a multi-CDN setup, no matter if it's a full-blown private CDN setup. We have to be available at any given time, meaning that when we plan for a CDN, we want it to be fully redundant. We want it to be resilient, robust, and potentially we could also mention something as self-healing and auto-scaling if we want to go much more into a containerized approach. And the architecture must be able to scale and shrink depending on the client traffic and the client needs. And again, this point is very much underestimated because when planning for a CDN, everyone will say it is obvious, it must scale. But as soon as we start discussing how it should scale, that's where the problems will start. So later in the slides, I will go through some of the scalability tips and some of the scalability issue we may want to consider in a CDN setup. And then, of course, as I mentioned at the very beginning of the presentation, like today, we don't really want to have a dumb CDN. We want it to be smart because we want to make sure we best utilize the underlying infrastructure. We want to make sure we create a very unique experience for the end users. And because of this, we are looking at the CDN which can handle different use cases. And here we refer to multi-tenancy. But we also want the CDN which can be fully programmable. And for example, in Varnish, you have the possibility to define different caching logic for different use cases or tenants using a VCL, which is the Varnish configuration language. So we want it to be available. Again, this will sound obvious. We want the CDN to handle unexpected peaks of traffic. So what I typically suggest in architectural discussions is that, yes, we should be planning for average traffic, but what is most important to consider in those kind of scenario is what could possibly go wrong. Like, we should be asking ourselves what could possibly go wrong and what happens if anything goes wrong. That's how you make a CDN available and robust enough to survive pretty much everything. And then, of course, to provide performances, relieve the origin servers, we want to try to deliver all the requests from the CDN. So if you look at this slide and those principles, I think we can divide those principles into two big micro areas. So we have the scalability part, and then we have the content protection and the content and the origin protection and the origin shielding macro area. And we're gonna focus on those two areas in the upcoming slides. But before that, another piece to build the puzzle, CDN roles. So up till now, we went through what's Varnish, the different components we need in a CDN, the principles we're gonna apply when planning for a multi-CDN or multi-CDN approach, or when building a CDN in general. And now we need to do a bit of considerations on the different CDN roles. If you remember the diagram I presented, the central part of the diagram, where the content distribution magic really happens, it comes with different solutions. So we need a routing solution, and this routing solution will have the scope of steer the traffic or steer the client to the closest available POP. This depends, of course, on the location and the availability of the different caching nodes of the different CDNs. Here again, we could resume the conversation we had initially around latency and geolocation of a routing solution. Based on my experience, and my experience really is mostly I've been working with CDN setups in the US, in Europe, and a bit in APAC. And to pick the right routing solution or the strategy you want to use when you need to route traffic, my experience says that perhaps a good amount of testing really is requested here. But typically, a combination of latency and geolocation works pretty well. So routing will send client traffic either to the closest POP or super POP. And now we zoom into a POP or a super POP. Typically, this will use a couple of layers of caching. Of course, it depends on the use case, business requirements, technical requirements, and also cost or the budget available, of course. But typically introducing 2 layers of caching, as I said at the very beginning, reduce the complexity of the setup and make it easier to administrate the full CDN, because then you can separate the different logical roles into 2 completely different layers. And that typically makes things way easier to manipulate and handle. The difference between a POP and a super POP really is that a super POP is comes with much more storage. But other than that, logically, they will likely behave in the same way. A POP can sit closer to a bulk of clients, whereas a super POP may serve some of the client traffic you're gonna have, but very likely a super POP will also serve content to other POPs. Let's zoom in again. If we look at what we have into a POP or a super POP, we're gonna have a set of edge nodes. And these nodes will they will be exposed to client traffic, and this traffic can be just regular pics, but it can also be malicious traffic, meaning that this POP will have to be optimized for bandwidth, TLS resolution, but those nodes will also have to be smart enough to either reject traffic or to load balance requests from the correct tier, from the tier nodes towards the storage nodes. And we want to do this in the most effective way. Edge nodes will eventually send some of the traffic to the storage nodes. These nodes, again, they are optimized for persistent caching. Specifically here, we want to use a combination of disk caching and in-memory caching. This caching is really, really good for any use case where you have a good amount of data to be cached. Just to give you an example, video on demand library, they are typically terabytes of data. And if we were to cache content on RAM memory only, first of all, it will be incredibly expensive to cache terabytes of data using RAM memory. But second, RAM is not persistent. So if you restart Varnish, or if you need to run maintenance or anything really, if you reboot the server, you will lose the cache, and that's terabytes of content. And it takes weeks in the worst case scenario to repopulate terabytes of cached content. And that's the reason why we want to leverage this caching to create a persistent caching storage. Equally, we're gonna introduce a layer of RAM memory, and this RAM memory will cache the most requested content as seen by the edge nodes. And that's the goal here, is to have a fast exchange between the storage nodes and the edge nodes. If we need to scale the storage nodes, we can scale them horizontally, so in adding more POPs or more nodes, or we can scale them vertically, adding more resources to existing servers. And last but not least, the origins, and that's where the content really lives. Can be in one single data centers, can be in distributed data centers. The goal here again for us is to reduce the stress the origin servers will see when content gets requested. Perfect. So now we have everything, really, all the most important principles and items to consider when building a CDN. So we went through what's Varnish, how a multi-CDN architecture may look like, different principles, different roles. And if you remember, at some point when discussing the principles, I pointed out that we could basically create two macro areas: scalability and origin protection. Now we're going to focus for a second on scalability. Scalability is, we can consider this a physical requirement, because when we scale a setup, we can either scale it vertically, adding more resources to existing servers, or we scale it horizontally, so replicating nodes and just making sure we have more nodes available in our setup. Again, if we look at this setup, and if we need to scale the edge tier, this tier will listen to clients coming from everywhere. And no matter if you're using a CDN, a commercial CDN, or if you're using a Varnish solution, very likely on these nodes, you want to terminate the TLS. Nowadays, pretty much all the connections are HTTPS. And we want to terminate TLS on the edge nodes. On top of it, we want to make sure that clients we want to give clients the content they are requesting. So we have to scale the bandwidth according to the traffic needs. And when it comes to scaling the edge tier, so if we discuss it, it sounds straightforward. And once you understand the different caveats, it is actually straightforward. But when scaling, one of the points of discussions I've taken several times is that when you scale the edge nodes, you will have to understand which is the best way to scale the setup. Obviously, we don't want to do this manually. So here we are already looking at a solution which implies auto-scaling. And auto-scaling can be really, really helpful if we understand which resource we want to auto-scale on. Otherwise, it will just be completely useless. So let's come up with some examples. Like if you scale based on CPU, this could be good enough in the sense that Varnish itself is not CPU greedy at all. So even when terminating a TLS, that will use slightly more CPU than the plain HTTP process, but still then that won't be enough to have auto scaling kicking in. So it's very unlikely that you see a Varnish instance utilizing more than or completely saturating the CPUs you have available. So that if you auto scale based on CPU, especially here I can speak for the Varnish experience, if you auto scale based on CPU, that will likely fail and it won't help when you have an unexpected load of traffic. Then you can second option, you can scale based on RAM. And again, on this layer, our goal is to handle incoming traffic. And the reason why we have two layers of caching is because if we don't find content on the edge tier, we can still rely on the storage tier. And that will introduce very, very little delay. Most importantly, it will introduce a delay for just very few users, and it won't have an impact on the overall quality of your service. So on the edge tier, we don't really expect to have all the content requested by the end users. Obviously, if possible, on the edge tier, we will try to cache as much content as possible. But if the distribution of the traffic and if the traffic patterns are really, really diverse, then there are chances that some of the content will have to be retrieved from the storage nodes. So some churn on this layer is somewhat expected, and that's fine. But it's expected because we're going to use all the available memory we're gonna have on these tiers or in these nodes. So expect Varnish or any other CDN solution to use all the available storage on this layer. So if you want to scale based on RAM, then there are chances that you're actually oversizing your setup, because let's an example, like let's say we're gonna introduce a new role when 80% of RAM memory on the Varnish node is utilized, then there are chances that at peaks, you're actually introducing way many more machines than what you really need to handle the traffic. And in some occasions, it makes no difference. In some other occasions, it comes with a cost. So obviously, RAM auto-scaling based on RAM is not a perfect solution either. The third option is to consider the request per second or the bandwidth utilized. And that's the most successful way to auto-scale on this tier. Really, you want to see if the bottleneck stands on the network available, then we want to introduce more network. And the easiest way to have more network and more bandwidth available is to add more nodes on this layer. And that's what we've seen working really, really well for other use cases as well. Then we move to the storage tier. Here the story is slightly different. So this storage will not be as dynamic, or this tier will not be as dynamic as the edge tier. So the scaling here may include auto scaling, but it can also be a manual scaling. So for example, if you scale horizontally your setup, then very likely it means you're actually mounting new disk within a rack. But you can also scale horizontally the setup, adding again more storage nodes, or even replicating completely a POP and making sure you replicate the POP or have as many POPs as you really need to deliver content to your end users. Here again, we scale the storage nodes when our the data set we want to cache grows, and we may want to consider scaling the storage if we have a low hit rate. So if the performance and the quality of experience for the end user is not good enough, and if we narrow it down to be the storage problem, then we may want to scale the storage we have available. So if we are to summarize how and what to scale, we can consider Varnish edge, well, not only Varnish, but really the edge tier and the storage tier. And the edge tier will likely scale based on, will scale based on CPU and bandwidth. Again, Varnish is not CPU greedy, but the CPU is, we need to consider CPU usage on the edge tier, because that's where we do the TLS termination, and that's a bit more CPU expensive compared to other operations. But the bandwidth really is what we want to scale on this layer. Whereas on the storage layer, we want to scale storage in general, and that can either be disk or it can be RAM. I have no secret recipe for how to scale disk and RAM, in the sense that obviously there are pros and cons to each of them. RAM is way faster, but it's also much more expensive than disk, and it is not persistent. Storage can be really, really slow compared to RAM. Today there are pretty snappy and pretty performance disk available, but it can be slow compared to RAM, but it is persistent and much cheaper than RAM. So the balance must be found there, and obviously it's there is no it's not set in the stone, and there is no unique rule for how to do this. And typically the discussions we take with our customers and the decision really must consider our other variables. So again, here we're looking at the budget requirements we have, performance requirements we have, and even the different use cases we want to cover and so on. For example, gaming, where ultra low latency is required, is different from delivering images for an e-commerce website. So those are two different use cases, and for two different use cases, we're gonna likely use the same reference architecture. We're gonna use the same principles, but when the question becomes, okay, how much RAM do I buy? How much disk do I buy? That's where the things become slightly different. But that's something we work on together with our customers, and it is an exercise of balance and finding the best solution given all the variables we have. And Perfect. And that was all about scaling. And now instead, I would like to focus on origin protection. So scaling, as I pointed out, is very, very, it's a physical part of the CDN, because whenever you need to scale, you are basically considering new machines, new nodes, and new resource requirements. When it comes to the origin protections instead, that's where the logical part of the CDN really begins. And when we want to protect our origins, we have to be clever at any given layer of our CDN. I'm gonna point out a couple of solutions here. Obviously, there are many other considerations to be done, many other tuning we can apply, but two of them are particularly important to me. The first one is content affinity. So really what we want to consider to start protecting our servers is the way the edge tier communicates with the storage or distribution tier. We want to make sure we make the best usage out of the resources we have available. And what will happen is that each of those three CDNs will request content to those Varnish instances. And just an example, if we have a set of clients requesting URL number 1, then all these clients will be distributed over the three different CDNs we have. So suddenly CDN 1, CDN 2, and Varnish CDN will see the URL number 1 requested by clients. And we don't really want the three CDNs to just send requests randomly to other nodes. We want to have content affinity in place. Content affinity is also known as sharding or hashing distribution. Basically, we want these three CDNs to know where to get URL number 1 from. So URL number 1 will either be stored on this machine or it will be stored on this other machine. There will not be a duplicate of URL number 1. And content affinity makes sure that the edge nodes will know where to retrieve content from the storage nodes. These, of course, improve performances, make sure we can funnel the request in the best way, and it starts protecting the origin servers because we're now sharding and distributing the content in the best possible way. And then we have another strategy we want to apply here. Now, this diagram in front of you, that's really simple. That's a single POP, but consider this at large scale. In a large scale, you have a set of POPs and a set of super POPs. And if we're not smart, for every time a client requests a new asset, every single POP will request this asset to the origin server. And if we have 200 POPs, then it means the origin servers will see 200 requests. And that's not okay. The goal for us is to have one request for the origin servers for every single asset requested. And in order to achieve this, we have to introduce a logic called self-routing. So we need to make sure that every single node and every single solution within the CDN ecosystem is aware of other POPs or other nodes. Self-routing in this diagram is represented by the red connectors. And the idea behind it is pretty simple. Before going to the origin servers, we want the POP to check one against each other if the content is available. If the content is not available in any of the POPs or in any of the nodes, then we're gonna send the request to the origin. But if we introduce this logic, then the origin again will see one single request per asset, no more than that. And that's the best case scenario. And if that happens, it means we have created a perfect funnel and we are distributing content in the best possible way. Those two, content affinity and self-routing, they are programmable within Varnish. And the content affinity is typically offered also by other CDN vendors. So that's a pretty standard feature available. But then again, here we're looking at the logical solution, meaning that Varnish here will play a very important role because we can implement self-routing and we can implement content affinity using VCL, using the Varnish configuration language. And there is something I said at the very beginning, and that's integration. Here, Varnish will play an important role because we also want to make sure that we play well with other vendors. So just to give you an example, and here again, that's all logical. It's not really physical at all. So we're not looking at machines to be scaled or storage to be added. We're looking at the flexibility of a solution. Varnish can integrate very well with all the other CDNs. Just to give you an example, for Akamai, for example, we have an Akamai connector. But for other CDNs, we have other capabilities which will play really, really well. For just another example, Varnish can create and send HTTP requests that will be extremely useful to create and invalidate content against against the POPs of other CDN vendors. So here, what we really want to do when building or considering a multi-CDN approach, really we want to consider Varnish as the glue. So obviously it makes sense to have to leverage different CDNs. It makes sense to leverage different vendors, especially for specific use cases. But the differentiator here is that we want to find a solution which can really integrate really well with other systems. And Varnish is extremely programmable, extremely flexible, and in my experience it plays very well with other CDN vendors. And that was my last slide for the long talking. At least I've created this slide again for you. On the right, you find the reference architecture. If you want, you can screenshot it and use it for other setups. And on the left, you find what we believe be extremely important to be considered when building a CDN. I hope you enjoyed the webinar. The goal for me was to try to share some of the pain points and the experience I've gathered through through the years and different use cases I together with the rest of my team been working on. And I hope this was good enough for you. And now we have, well, first of all, thank you. Now we have a bit of a Q&A if you have any question for me. Let's see. So I'll start with a question. So there is one question: how does images? Basically the question is how. I assume, John, you want to know how AWS images will play in a multi-CDN setup, really? I'll try to answer that one. Let's go back to this diagram. Let's see. Let's go back to, even this diagram is fine. So that's an architecture. And this architecture can be deployed on bare metal, can be deployed using containers, can be deployed in using an hybrid approach. Typically, what will happen is that if you go to a CDN vendor, then you come up with requirements, you come up with apologies, you come up with the amount of storage you need, you come up with bandwidth you need, and they will allocate some storage and bandwidth for you. When it comes to Varnish, Varnish will Varnish can run on bare metal in the cloud or even containers, and really it will just work. I've recently worked on a setup where we deployed a CDN, a Varnish CDN in AWS. So that works very, very well. Obviously, there are pros and cons again. So for example, we have seen a network load balancer working better than an application load balancer. And that's something you gain while testing the setup. But it will just work. If the question is, what is best? I cannot answer that question because I think there are good use cases for bare metal, but there are equally good use cases for container setups, and even good use cases for an hybrid solution. Let's see. I have another question for self-routing. Best practice when there is a self-routing setup and one of the Varnish storage servers is not available. Good question. So the logic behind self-routing is that each node is aware of itself and the other nodes. And actually, before getting there, one of the things you really want to introduce in your setup, you want to consider health checks. So that there will be no self-routing if the server is not available. But in the unfortunate case where the server is not available and you try self-routing, then you will get just a reply back, which will basically tells you that's a 503 or a 500. I'm not sure which one of the two, and you will retry against a different node. It is basically just like selecting an origin servers. So when you introduce self-routing, you are considering a Varnish node as any other origin servers / backend. I think there is someone raising hands. Can you write down your questions, please? Okay. Oh yeah. Oh yeah, Frank. So you can look at this in. So the question is if we use realloc over malloc. I don't know by heart all the code lines of our source code, but most of the memory allocation in Varnish, at least the open source, is done using malloc. I will have to double check with the engineering team if we are using other strategies for MSC. MSC is our massive storage engine, and it provides persistent caching, but it also provides an optimized memory in-memory caching. So I'll double check it. Okay. Is there any other question? I'm looking at the chat. And I think no. I see there may be some other questions, so I'll wait a couple of minutes more. Okay. Okay, I see no other questions, so I will close this webinar now. Thank you very much again for taking the time to join me today. I hope you enjoyed the presentation and have a good rest of your day. Thank you. Bye-bye.